I think it's very easy for the media, for the press to seize on any new scientific or technological development as something that's going to be transformative. You know, scientists come up with these amazing new materials and then everything changes, and of course it never really happens that way.
Brief history. Graphene was initially labeled the material of the future, and for good reason. It was first extracted by Angelo and Konstantin Novoselov in 2004, where they used the seemingly non-scientific method of extracting it from pure graphite.
But the actual researchers in the field didn't do anything that more complicated. What they did was they got a crystal of graphite, I've got one here, and with a bit of tape, you put that on the crystal. And actually you do this a few times to remove the impurity. You take a fresh piece, put it on the crystal and pull it out. And actually what you've got is fragments of graphite picked up by the tape. Now if I bend this over, what we can do is we can then capture the graphite on both sides. And as we pull it back again, we can separate out these fragments of graphite and split them in half. And if we keep on doing that with these fragments, using this sticky tape, we can actually halve and halve and halve and halve these graphite fragments. And eventually you can make single layer pieces of graphite. In other words, you can make graphene sheets by nothing other than a piece of tape and a bit of pencil, basically.
Graphene is able to be extracted through this method, as graphene is really just a one-atom thick sheet of graphite. Therefore, like graphite, graphene is made up of carbon atoms joined covalently to 3 other carbon atoms, but without the van der Waals bonds that hold graphite layers together. The covalent bonds holding the carbon atoms together are strong because of carbon's high electronegativity due to its relatively small size and the lack of shielding, and so there are strong electromagnetic forces of attraction between its negative electrons and positive nucleus. As well as this, every carbon atom has a delocalized electron, which allows graphene to conduct electricity. This fourth valence electron is dubbed delocalized because it's shared in common with other carbon atoms. Graphene has many properties which make it an incredible material for both technological and industrial processes. These properties include high electrical conductivity, high tensile strength, it has a high thermal conductivity, it's very light, and it can be very small. This has opened up new possibilities for the material in areas such as nanoprocesses, construction, sensors in the blood to monitor health, space travel, and water filtration. There haven't been any real technological breakthroughs with the use of graphene since its discovery in 2004. This is due to graphene being a very difficult substance to extract commercially, and so research is being done into methods of mass producing graphene in a way that is economically viable. And because of this, experts predict that it may take several years until we see a graphene revolution.